Okay, hello. Um, Welcome to the stream. Today, let me just get ready and then I'm going to start. I have a slight headache and I don't know exactly why. Maybe because I had 2 coffees recently. I think I'm gonna go get a banana. Hello, Farfadet. Let me just eat this banana. So, updates. Okay, just looking at my to-do. What do I need to do before starting? Okay. So, just a minute. How is everyone? Was your day okay? It was pretty hot today, but not too hot here. A few days ago we had like 35 degrees Celsius. It was really hot. Now it's fine. Okay, I think I'm ready. So, let's start. Hello. So, what are we gonna do today? As I've said in the tweet, I'm basically going to continue where I left off, and there won't be any long intros like usually. I realized that every time I look at these updates since last time, I'm like, okay, I'm just gonna say them and just show it a bit. And it turns out that all this stuff takes at least 1 hour. So the first hour of each stream is just like what happens since the last stream. So whenever I say I'm gonna do this on the stream, I never end up doing that thing in the first hour. So it's always annoying. I mean, it's just maybe it's not annoying, but I feel like it's annoying because I announced something. Like yesterday, I said I'm gonna do Blender geometry nodes, and then I went on to showing all the other stuff, all this stuff. Okay, anyway, so on this stream, I'm gonna go right into the business. And first thing first is that yesterday I couldn't figure out what. So yeah, here is my Blender. And most importantly, if you look into the lower right corner, I don't know if you can see, it says 3.1.2. So that's the current version of Blender I'm using. It's the stable version. And the thing is that I had this problem with UVs. So what I did is, as you can see here, these two are the source objects. Wait, let me move this a bit. It's all my fault. Yeah, no, it's not your fault. No, that was like when I was doing the night stuff, it was yeah, that was the second hour, I think. It was not the first. But that was fun. That was, it's definitely not your fault. Well, that was a fun part of the stream, I think. I think I got many people activated and engaged into the stream. Hello, geometry nodes are so great. Yes, they are. There are some things lacking, which I'm going to just show, which is unfortunate, but it's getting better and better each Blender version, and it's just crazy how fast they're developing Blender. I mean, every 2 months there's like a new version out. Yeah, I'm going to show you that. Oh, I just remembered something. Give me a minute. Okay. Anyway, yes. So last night I had this problem of like, so as you can see, these two are the source object. So this is the pillar, as I called it. Oh, the UV is kind of, oh, the UV is very squashed. You can see, you can see how the pixels are. I should probably like widen it a bit. Wait, oh, I never saw this button back to previous before. Nice. Let's go to not shading, UV editing. And let's, oh yeah, I didn't even edit the UV, that's why. This is just the native UI, the native UV. So yeah, something like this, except the bottom and the top should probably be like white and much smaller. We can also, there is a thing in the UV options that says average island scale. Here it is, and it's basically what it does. It will resize the islands to match about the same texel density. So the density of pixels on this side is now approximately the same as density of pixels on this side, on the bottom. It's a bit hard to see, but yeah, that's how you kind of average. So, and let's make it like not like this, like it looks like it was cut, like it was cut sideways, but it's actually longitudinally like this. Okay. And maybe a bit bigger pixels. Something like this. Okay. Cool. So, The problem I had yesterday is that I couldn't really get the UVs of my base elements into wait, so let me use a flat and texture so we can see the pure texture. I couldn't get it to render on these on the guardrails on the final. As you can see, they're completely white, even though the guardrails themselves are using the same material. So what is going on here? And the problem is that the curve. So the problem is that the base, the type of this object is a curve and not a mesh. So what that means is that it doesn't have the same properties as a mesh object. So if you have a mesh object, like a plane, right? You have a mesh object, which is all the way over there for some reason. I didn't actually need to make this because these are also mesh objects. So for example, this pillar here, as I call it, I call this the rail and this the pillar, right? So the thing is that this pillar or this rail, they're mesh objects. So you can go in there, you can edit the vertices, right? But this is a completely different type of an object. It's a spline, right? It has spline Bezier points, right? It doesn't have vertices, or like it only has Beziers. So what's the difference? The difference is that when you click on this, you can see that it has completely different properties. The curve has different properties. The elements have different properties, and the problem here is that if we go here and we go into the mesh, right? This is like object data properties, right? There is this category called object data properties. And it has all these properties, which are UV maps, vertex colors, which there are none, face maps, I don't know exactly what this is. But it has all this stuff, right? Normals and stuff. But curves don't have that. So they don't have this object data at all. But thanks to geometry nodes, we can actually join some geometry in there, and the output of this geometry node is actually a mesh. So that is what is the confusing part. It, as a source object, it doesn't have any of these data arrays, right? There are no UV maps, there are no vertex colors as part of the curves, right? They're only part of the meshes. But since this is a curve, it doesn't have them. But the final object, when you actually when you convert it into a mesh, it does actually get these arrays, right? The UV maps, the vertex colors. And the strangest thing is that if you look into the data inspector here, you can see that all this data actually exists, right? There's position, well, position exists for curves as well, I think. Oh no, it doesn't. There's control points, right? But the thing is that if you click on the face coordinate, you can see the UV map, but it doesn't exist here. So that's really, really strange. Like, it exists kind of in this geometry nodes debug parameter, but it doesn't exist on the actual mesh. But if we create one by clicking on plus, suddenly we get a new UV map, but it overrides this old UV map. So you click plus, and it's like, oh, now we have created a new UV map. It's such a weird thing. So I think that the reason for this is because this is not really entirely complete when it comes to a Blender. You know, because geometry nodes are very new, it doesn't work in the same way as it would, as it should, right? Because like you can make all these nice renders with the custom attributes and stuff, which I haven't even mentioned. but yeah, they didn't. So the thing is that Blender devs maybe didn't really plan on like supporting exporting of UV maps or custom UV maps initially, right? So they started making these a few of the tools so you can actually convert custom attributes into maps. So, for example, here's what I can do actually. There is a thing that's called attributes, right? And this, oh, okay. Well, I just said something completely which negates what I was talking about previously. So the thing is that this UV map actually does exist here, but I failed to mention that it doesn't exist as a native UV map, right? What it does exist as, it exists as a attribute. So the attribute is this completely separate thing from the built-in types that already exist and that already existed in Blender forever, right? This attributes thing is a completely new thing that was introduced with geometry nodes. So, hello, I had the same UV problem. Hello, Joan Loop 42 for the same kind of assets. Yeah. So as you can see, this UV map exists as an attribute, but it doesn't exist as a UV map, which it should. But what you can do is there's this little drop down arrow that you can see, which is like attribute specials. It's completely impossible to notice it, right? If you don't know where it is, right? You click on it and it says convert attribute. Oh, nice option. You click on convert attribute and it tells you, okay, what do you want to convert it to, right? And you say, okay, let's convert it into a UV map. You say, okay, and here we go. Now this data is converted to an actual UV map that is on the mesh. So it is a really, really weird workaround. But it does work, right? Now I have the UV map that I started with. So this base UV map, right, is the same as this UV map, which is cool. So this is how you kind of fix that issue by having this. The problem is, though, is that you need to apply this every time. You need to apply the geometry nodes, and then you need to convert them as well, which really sucks. So the thing is that you can, so I'm reading the chat message. You can fix it within the shader editor with an attribute node as an input to the texture node. Yes, you can. You can have your custom attribute node. So instead of reading from the normal vector, which is your UV, you can add an attribute and then read it from this special name. Let's call it UV or something. I don't know. And then you have to export it from geometry nodes as like I know that I've already dealt with that before. Then you have to also here export the geometry as like this. You have to capture the attribute, then drag it over and put it inside the custom attribute and then read. But the problem is that it won't export because I'm working on a game, right? I need to export this model with the UV data and I need to be able to read it inside a game. So that doesn't work, right? Because I still need to convert this attribute. Hello, Loms. Nice to see you. And it works without applying the modifier. Yes, it does work. Like you can see it live. At least that's good. But then you still need to convert it at the end, right? So I actually made for the conversion process. I made actually I actually made a little GitHub repository for where is it? B3D attribute converter. Yes, so I actually made a little script. I made this maybe a month ago. Oh no, 4 months ago? Oh wow, that was so long ago. I didn't even realize. So the thing is that this kind of gives you the ability to click on the. Wait, is there like, this is like a one command thing. I even forgot how it works. Attribute? No. I have to read how it works. It was so long time ago. Simplifies converting attributes, creating by... okay. How to use. When you call the add-on, useless panels will appear on the right side of the viewports. Okay, maybe I don't even have it installed. Yeah, probably I don't. Anyway, I won't use it. But the thing is that what I did here is I made like a one-click thing where you don't need to, for each object, you don't need to go like, okay, convert to mesh, now convert attribute to UV map for each single object. What you do is you do that with one click. And then it converts all attributes. Okay. So that is one part of the problem. But the reason why I don't want to use this plugin is for this thing. I put on the top which says, warning, this is a hack for a soon-to-be deprecated conversion process. Since at least Blender 3.3 Alpha, the Blender attributes have been completely overhauled, and now values can be stored with store named attribute node into output attributes directly, and the entire hacky conversion process that the script simplifies is completely unnecessary. So the thing is that, this is why I said on the beginning, look at what version I'm using. I'm using 3.1, right? Is it 3.1? Wait a minute, I just realized that, is that Blender? Okay, I need to check which one is the, actually, is 3.2 a more stable version? Wait a minute, I'm using a 3.1. How is that possible? Isn't this a 3.2? Wait, did I forget to install the new version? Okay, well, it does say 3.2. Interesting. Okay, wait. Let me restart Blender. I thought I had 3.2. Uh, 3.1.2. Oh yeah, really? I'm not using 3.2. Wait a minute. Interesting. Okay. So I was okay, let's actually install the new version. Okay, let's see if 3.2, because I was about to open 3.3 alpha, which has that fix, right? But maybe 3.2 already has that. So let's just live install Blender. Okay, that's great. It's probably gonna take a while. But yeah, let's see if it actually fixed, if there is a new store named attribute thing in 3.2. Like, right, I'm not actually sure. But there is another problem in 3.1, which I want to talk about a bit. There is another problem because of the, geometry nodes are not yet very good. And 3.1. And the thing is that because this base, the how do you call it? How should I say? The object type is a spline, right? It's a Bezier curve. And the thing is that, oh no, we have this ugly separation. We probably just need to increase the resolution of the curve. Nope, that doesn't fix. Okay, then just not have very, very sharp corners. Anyway, what did I want to say now? Yeah, so the problem is that if we look at my geometry node, which is beautiful, this ugly part is just for calculating the offset of each of these planks in between the poles, right? Because I have to divide the length by the number of by the target length, and that by the target separation between the two poles. Then I need to floor that. Then I need to divide again so that I calculate the approximated position. Then not the approximated, but like the true distance between the two. And then in the end, I multiply by 0.2 so that I offset it, and then I subtract the length, right? Length minus half distance and half distance, right? So that's actually that gets into the points. This creates the points of the for the rails for these horizontal poles, should we call them, right? Anyway, yes, it does work. It does have a little bit of issues, as we've seen in these like edge cases. If it's long enough, it's fine. But in some of these like super sharp corners, it does get a bit separated, which is annoying. But we can live with that. It looks fine like this. Anyway, yes, a little bit of a side thing. What did I want to say? Yes, one of the problems in 3.1 is that there is no way to get a UV. Oh yeah, let me tell you what I was trying to do yesterday on the stream. Remember, if you've been on the stream yesterday, what I wanted to do is because the UV map, the UV of this pole, horizontal pole, is actually just constrained into this corner, right? If you look at that, you can see that this is the and then I had this idea, right? I had this idea, what if for each of these instances of the mesh, I wiggle the UV a bit, right? I say, okay, what if I move it slightly like this, slightly like that, slightly like that, slightly like that? Basically, I get like infinite variation in the UV, right? Imagine that one of the poles is like this, and then one is like this, and one is like this, and you have this also discoloration and this darkening that I painted yesterday actually in Photoshop Live, but then I didn't manage to make it working until today. Well, hopefully today on the stream. So yeah, I wanted to wiggle this UV to create a sort of like infinite, variations of this horizontal pole. You could do it directly in the shader in Unity, though. Well, this is the thing. I'm not using Unity. I'm making the game in my own engine. I mean, still, I could write a shader to do that. That's true. But then, what do you use as an input, right? What's the input for the offset? Just the position of vertices or something? So, but the thing is that why not make this all in? Oh, why is my animation running? Yeah, that's because I accidentally pressed Shift Space. It's the most annoying shortcut instead of Control Space. When you click Control Space, by the way, you can maximize windows, which is very useful, especially for streaming when you're like, okay, I wanted to look at this. Okay. Float 2 in a buffer, 1 per instance. But how do you define instances? Like then it's not really a mesh anymore. Then I need to pass individual, and I need to have some kind of GPU instancing or something. I need to pass an array of instances or something. Because this whole thing is going to be baked into a mesh at the end. This whole thing. I don't really need to have individual instances separate in the engine, right? This is all going to be the one mesh. That's what I want, kind of. But the thing is that, so yes, let me get to my point, right? My point is that if your base type of the object is a spline, and we have already said that you don't have this vertex data. You don't have the same vertex data as the mesh. Actually, there is no way in Blender 3.1 to access the UVs of this instance. There is no way. Like I at least I couldn't find any way. So if I go into geometry nodes, so click on this one. We'll look over here, and I pressed the wrong button again. Okay, so the thing is that if you open up a capture attribute, for example, so this is the funny thing, right? If you go into the mesh geometry, you have inputs, right? You have position, you have normal, right? You have some radius and whatever, index, ID. But there is no UV, right? Those built-in attributes don't exist in 3.1 in geometry nodes. The only way you can get them is through an input through the attribute, right? You say capture attribute, and then you get this attribute from the geometry. But the thing is that I don't have, if you have like, where is my object, right? There is the object, right? I get my geometry, like this, and I can point into some kind of a custom face corner vector, which is not really UV, right? This is a custom attribute, but the thing is that where do I get this value from? I can't, because there's no UV here, right? You have the location, rotation, scale, there's nothing else, right? You can't extract UV from the object info. At least I couldn't find how. And the thing is that in a mesh, right? When you have a mesh object that is a mesh, and right, if you have some mesh, you create a new geometry node. Let's call it Blur. If you have that mesh, you can get a custom attribute as like dragging this, and not like that. You can't do that. You can open this thing, and then you can say. You can create a new input, and you can say, okay, I'm gonna get it from, I'm gonna call it UV, right? And I'm gonna make it, so it's gonna be a UV. So, and it's not gonna be geometry, it's gonna be a vector, right? And so the vector, now I can pass it into the capture attribute thing and get the attribute, right? But the problem is that it needs to be added as an attribute. You need to go here, and in the geometry node you need to point this into a UV map, right? You can say, okay, my UV intro attribute is the UV map. But the thing is that you can't do this if your base type is a spline, because there is no input UV map. There is no UV map on the spline. So there is absolutely no way to get a remote UV in a spline type, which is a bummer. But actually, in a newer Blender, either 3.2 or 3.3, I don't know, you can actually get. So that is why I'm gonna say screw Blender 3.1, and we're gonna go on and install 3.2, because I'm not actually sure if this is the version in which they've introduced the new stuff or not, right? I'm just, all this time I was just showing you how things how the old versions couldn't handle importing custom UVs into a it wants a new Blender 3.2, but isn't that already existing? I don't know. Okay, let's install 3.2. So yes, I'm going to show you then when I install the new version of Blender. If the new attribute system exists, which I already talked about in this thing, right? So in the new versions of Blender, now you can actually get those base attributes without having to make all these custom attributes. It kind of seems like, to me, like the team in Blender that worked on geometry nodes didn't want to touch the stuff that already existed or some other team worked on. So they made this parallel universe attributes, right? Which then you can customize the output. And it's kind of weird that there's also the types. There's vector type, but there's no vector 2 or vector 3 type, right? It's just a vector 3 type always. And UVs are usually 2 vectors, right? So I think that in the newer versions, they're going to kind of use both. They're kind of going to unify attributes somehow, so that you can use the built-in attributes. Let's call those built-in attributes, and then the geometry node attributes at the same time, right? Yeah. So thanks for joining the stream and watching me install a new version of Blender. Register in product? Did it say register in product? Do I need to pay something? Hope not. Okay, so anyway, let's see. Yes, so what if I click on 3.2 now? No, okay, it doesn't exist. Oh no, 3.2 still exists, right? I need to go into... I need to get my programs. Program files, right? And get the newest one, and then say Blender Foundation 3.2, and I should probably uninstall 3.1 because it's just... I've just proven how terrible it is. No, I'm joking. It's still fine unless you're using the newest features like I am. So let's add this. Nope. Let's add this into my shortcuts. Rename this to 3.2. For some reason it wasn't 3.2. Okay. For some reason this is 3.1 actually. I was wrong about this. So let's just rename it quickly. 3.1. Okay, so let's see what kind of splash screen they have now. Hopefully I can just easily transfer my old settings into the new version. Let's see how Blender handles that. I had problems only once when my settings file got corrupted somehow. Oh, what is going on? It's the gray screen of death. Why is it so slow? What is going on? Wow. Okay, nice boats. Okay, so for sure I haven't used 3.2 before because I haven't seen these boats. So yes. Oh wait, is it already using my settings? It is, right? There's no... Oh wow, okay, so it was totally automatic. Nice. Okay, so let's go into geometry nodes right away and just see if they fixed actually... if the new stuff exists. Attribute. Store named attribute. It does exist. Store named attribute. Yes, perfect. Okay, so I don't need to use 3.3 alpha. That's great. So I can use the stable version of the Blender, and it has all the new features. So what is new? What is new in the new geometry nodes? The new thing is these things, right? It's called there's two new nodes, right? There's a store named attribute and remove named attribute. Wait, was there another one? It's definitely not a store. Wait a minute. I have to check in 3.3 alpha because maybe it is actually missing some attributes. Float 2 in a buffer 1 per instance. I don't know. I don't know what you mean by that. Okay, so geometry, attribute, store name, transfer. No, it's actually exactly the same, right? Store and so now I need to remember how it works. Okay, so it's definitely the same, right? Let's see. Maybe 3.3 has some new nodes, but for now I think this is going to be fine. So yes, there's a new thing that is called a store named attribute, and what it does is that you can fetch a attribute from the geometry now, which is named. So so this is what I call built-in attributes. They actually call named attributes, right? So if you connect a geometry and you connect to the end, right, you can get the attribute from geometry itself. So instead of having those capture attribute things, now you can get the named and you can get it directly. You can say UE map, there it is, and I got it here, but it's not actually there. It should be a vector face corner, right? So it should be here, which already it was here, right? Originally, which if we connect it like this, right? But the thing is that we do need to provide it the original values, right? So it is. So instead of having this capture, you remember we had this attributes. We had this convert attribute. It still exists, right? You can still convert attributes, but it is kind of not needed anymore because we can store the named attribute directly into the UE map. So the UE map is now directly going to have this value of this. So yeah, it's completely the whole script I made is completely unnecessary. But the thing is that how do we get this attribute? And now I need to remember how this happens. Remove store transfer. Is it no? Not this. I need to remember how I did this. Okay. Capture domain. Store named attributes. So capture. Can we capture the UV now? I don't think so. Face corner. So somehow I managed to do it last night. And now I need to remember how I did it. With these nodes, I'm pretty sure there was another node where you could input, where you can like extract the. I need to go into 3.3 alpha again to make sure that I didn't miss something. Okay, so this is where I experimented in this new attributes blend file. So let's see. Okay, so what did I do there? Named at. Wait a minute. Oh, it's the input. Okay, it is in the input. Okay, sorry about that. I had to check. There it is. Okay, yes, let's shut this down. So yes, here is how you do it. So this is how you store an attribute, right? And if you say, okay, I want to store it in the UV map, you can set it here, right? But how do you actually obtain the input, right? No longer do you need to do this with an attribute like this. What you need to do, what you can do is use the input. And here, this is what I complained a few minutes ago when I was in 2.1. I was saying how you have position, you have normal, right? You have normal. You have all these like built-in things, but where is a UV map, right? There's no UV, there's no colors. Well, now there's input named attribute, and you can actually get an attribute and plug it directly, store it directly into your custom attribute. So I say, okay, the UV map, it's a vector. It automatically knows it's a vector. And if I plug this in, there it is. Now my basic UV map is there. And what I can do now is, well, if I have some kind of a texture, right? If I have some kind of a texture on it, let's just see. Okay, so to get a base color, image texture, open. Let's see. Surfaces. Let's get some nice mud road. No, tarmac. Okay, some nice tarmac. Okay, and they need to show it so it renders the texture. And we can see that we can't see anything. Why is that? Let's figure it out. Oh no, wait, let's not use tarmac. Let's use something more clearer. Noise bilinear. Wait, there is a thing. There was a thing. I have this. Where is my UV? Okay, let's use a car texture, you know, because it's kind of a you know, you can really easily see the detail, right? You can see what that it's using different UV. So if I go into the UV mode and open the UV editor, and yeah, you can see that it's like a cross. Right? Yeah, I can move it manually. But what if I want to like move it programmatically, right? I want to move the UV. I need to offset it or something. So what I can do now is if I connect this, okay. For some reason it still doesn't work. So that's a big fail for me. Wait, so this works. Okay. This doesn't work. Why? Because it's a 3 components. And it doesn't actually get converted automatically. Okay, so actually, after all, we have to apply, we have to still convert the attributes, it looks like. I had a feeling that it worked in Blender 3.3. Okay, let's see this. This might be like version hell now. Because I think it actually works in 3.3. Texture. I might be wrong. It might not work actually. So slow. Vehicles. Spec body. Okay, let's do this. Wow, it is so slow. Maybe because I'm just running 2 blenders at the same time. Okay, so we have the same thing, right? We have the same UV. And yeah, let's add geometry nodes. Geometry nodes. What do you want? Okay, so let's try the same thing, right? We have an input, which is a named attribute, and it's going to be a UV map. Okay, so this is something interesting. Oh no, it's not interesting. Actually, it's completely the same. Okay, between versions. Okay, we have this attribute. Oh no, wrong. And we are going to what I'm going to do now is I'm going to capture the attribute. No, I'm going to store the named attribute as UV map. Face corner, it's going to be float. So exactly the same thing as I was doing. Oh, look at the wait, face corner. Yep, there it is. I pass in the value and it completely disappears. Yeah, so the UV is not working actually, even in the new version. Why did I think it was working? That was really weird. Okay, I thought I totally fixed this issue, but now there's still an issue. It's such an annoying process. But anyway, yes, we should be able to store the UV. At least in the new version, we can actually fetch UV from objects. So yeah, the UV map exists. If we apply, yeah, let's convert to mesh. Okay, it did actually convert to attributes. Okay, so at least this is nice. So we don't need to plug attributes anymore into a group output. So this is a different thing. So we don't need to use capture attribute anymore. We can just store it into a known thing, right? So this is a funny thing, right? This is what I was talking about. A UV map is a 2D vector, right? It is a 2D vector, but we can't actually store a 2D vector. You can store a vector. There's no 2D vector. So what happens is that it gives you this UV map with 3 components instead of 2. So if we just put the input geometry into the output geometry, we can see that the UV map is 2 component, right? This is the original UV map. But if we pass in our custom UV, it is not. Now it becomes 3 component and it completely screws up our final mesh, our final UV. So if we convert this and then we have to convert again into the UV map, then it works, right? Then it converts into a vector. Okay, I hope that they're going to actually fix this in future versions, that it's going to become a 2-component vector and not a something that we can like output immediately. But look, as who was saying that? Jean Loop was saying that you can actually still display the UV if you use a custom shader. So okay, let's try making a custom shader. We have the cube, which is completely black now. And let's add a attribute, which we're going to say is, oh, there's no named attributes. Okay, let's call it UV map as it was. Let's see if that works. Okay, it does work. So as you can see, we can actually display the UV maps into shader, but we still have to go through this process, right? If I say convert attribute, okay, and then I apply it, and yeah, it's a UV map, I still have to go through the whole process of converting the attribute, which is really annoying. I really don't want to do that for everything in my scene, right? Okay. So I don't know if this is even interesting to anyone. my messing with Blender versions and showing how some tricks are done, because it's kind of a boring process, which I just realized doesn't actually work in the same way as I thought it does. But we have found a workaround, so we can still. So yeah, the cool thing about getting a UV. So why did we even do any of that, right? You might be wondering. Well, because we have this plug from attribute into a value, we can now get this. We can now do whatever we want with this attribute. So, for example, we can math like always. So let's we can add an offset. So we say, okay, let's move it a bit, right? And so we can move the UV, as you can see. If you press shift, if you hold shift, then it's smaller increments, right? So as you can see, I can offset the UV now, and it gets stored into UV. So that is pretty cool. I don't know, you could even like offset it by position or something, right? You can say, okay, let's take position and then offset it, and then you have this funky skewed UV, right? Or something like that. Or you can change the size of it. Or you can randomize. Yeah, you can like change the size, the scale with a scale, right? So yeah, now it repeats. Now there's a lot of cars in this, a lot of little cars. So now when we actually convert it to a mesh, and we have to again do this convert attribute thing, we actually do get a UV which is applied. But the reason why this didn't really work in the previous versions was that, as I was saying, let's go into, is this 3.3? It is. Okay, so we've all been working in the old. Okay, so let's go to our main scene, right? Let's go. Yeah, I have to open the track now. I have to open the track, and I'm going to have to save. Oh, there's the track. So let's now save it as a new file, just in case something broke in the new Blender version. So I'm going to call it track Blender 3.2, right? Okay, so what was I talking about? I said that instead of capturing attributes, we can now get this UV and output it. So first, let's make that as I was saying, the attribute shader, right? So instead of using this, we're going to pass UV map from geometry and pass it as a vector. And now I don't know if we're going to see anything. We're not going to see anything as is. Oh no, we do actually see it. Okay, so this actually works right away. Which is great, right? But the problem is that I wanted to wiggle this UV, right? I wanted to wiggle the UV, and I couldn't do it in the old version because we couldn't get the data from not curve object. But now I can actually get a data about it in the same way as I did over there, right? By getting an attribute, input named attribute. And let's get a UV map. As you can see, this is what didn't exist in the old version, right? You couldn't get a UV map because our base type of the object was a curve. So the curve doesn't have a UV map. But now, in the new version, you can actually get a UV map. And to get it from this object, right, in my case, this is actually the, what type is it? It's the pole, right? Let's not get it from the pole. Let's get it from the other thing. From the rail, as I called it. From the rail, yes. So now we say store named attribute, and we say this, and then we plug the named attribute input into the value, but it needs to be name, we say UV map. So this is a face corner. Whoops, this is a face corner. Plug this, And now let's see if something changed. Nothing changed, which is great, which is exactly what we need. But we can now play around with this. Well, no, it's a bit messy. Beautiful spaghetti. Hope nobody is hungry. Attribute. Okay, so we can now let's do the same thing that we did before, right? So I need to use vector math. I put it here and I can offset it, right? And as we can see here, if you can see in the output, we are actually offsetting each instance, right? The x UV of each instance. But what I want to do is actually, and as you can see, we're only influencing the pole and not the whole object, because this is amazing. This would not be possible in the older version in Blender, right? This can already be done in 3.2 and above. Oh, the garbage people are here. Okay. So I'm very happy about that I don't need to use the unstable 3.3 alpha. So what do I want to do now? I want that for each instance, I want to have, so basically, what we have here is we're getting an object. We're getting this rail object. We are then transforming it, right? Because I need to kind of offset it a bit to, yeah, like put it in front of the pole. So that's basically what it does, right? It's oh no, no. There is no undo. Oh, there is undo. Okay, good. I hope everyone on stream is having fun watching me struggle. If you have any questions, ask away. So let me think about it. Yes, we're moving this. We're moving the object. What is this rotation? Oh yeah, right. We're rotating the points. Let me just collapse that for a bit. Instance and points. So yes, I am spawning points on the curve, right? And then I'm instancing this object. But what I really want to do is I want to randomize the UV of each instance. So how do we do that? Well, let's figure it out. I don't know, so let's figure it out. Let's see. So what I need to get is, so instead of this, yes, so basically I need to unplug this. I have to move this thing in front. Whoops, this whole thing. I need to move somewhere in front, so that it works in instances and not on our kind of base object, right? So instance and points, right? And then for each instance, I want to change the named attribute. So let's try this, right? Can I actually grab the geometry and just do this? Is it going to work? It does actually work. Right? It still works, even if I'm operating on each of the instances. Perfect. Okay, this is amazing. Okay. So one thing is that I need to randomize. How do you randomize? You have a random, right? Random value. But the thing is that I want to use the ID of instance. So how do we actually get that? I have no idea. We have instances. And so there is a thing called instance index, but it's an input. It's not an output. Can I get instance ID somehow? Instance ID. Let's look for its ID. Instance. No, not realize instances. Instances to points. Geometry to instances. I wonder how do you convert get instance ID. Yeah, Blender geometry nodes. How to access GeoNode generated instance ID from cycles. No, this is something. I generate some instances. Each instance has an ID attribute. You know what? The thing is that I think because it has this instance, instances, right? But each instance, the problem is that I don't have a view into it. Wait, viewer. So if I plug in these instances, right? I should be able to get a view into my instances. There it is. Okay. So what the viewer does, viewer will just output the data of wherever you want in the node graph, right? So if you connect it to a viewer, you can then open this instance view. And so what we can see here is that my instance, as you can see here, each of the geometries has an index 0, 1, 2, 3, 4, 5. And how do I actually get this index? That is a question now. So there is a thing that is called an index, right? You can get an index. But how do I actually use this index? I think maybe I need to capture the attribute. After all. Capture attribute instance integer, and then I use an index, right? What about this? Is this going to work? Is this going to work? So let's plug it in the attribute. Okay, there it is. Wow, it's using a float for it for some reason. Why is it using a float? Okay, so it does work. Look, we have 0, 1, 2, 3, 4, but for some reason it is a float. It does use a 0, 0, 0. Not sure exactly why. But anyway, good news that it does actually work. Just a moment. Okay. The momentary break is over. So we have managed to obtain an index. What is amazing is that I didn't even Google this problem. I just managed to get the attribute through thinking. You know, that's amazing when it comes to me. I mean, I'm surprised myself that I managed to figure this out on my own. That's experience, I guess. So, capturing an attribute. So now we have this attribute of index, and what we can do is we can pass that to a random generator. We pass it as an ID, right? Or we can pass it as a seed, right? Should it be a... I don't know exactly. Okay, so we have this named attribute. Let's add a value, right? Let's add a value. And now let's see, let's increase the maximum. Is this the ID, or should I use a seed for that? Actually, the maximum should be 1, to be honest. So let's see if that works. I don't think it works. No, they're all the same. Okay, so storing named attributes into the geometry. Let's not use evaluated. Okay, so I think maybe I don't need to use the ID. What I need to do is I need to put it into a seed. Does this work? No, it's still the same. Okay. I'm not smart after all. Maybe I'm misunderstanding something. So the thing is that I'm actually injecting this value into an instance, right? I'm not injecting it into the final mesh. So I'm capturing the ID of the node, right? I'm capturing the index of the instance. And then for each of an instance, I'm storing a new UV, which I'm adding a random value. And this is a viewer. Let's kill the viewer for now. Let's see. So if I unplug this, oh, maybe it's because it's a float, it's not incompatible or something, but it is convertible. No, it's still the same. It did completely screw it up though. So it does do something. What if I just directly add a ID, right? Instead of having a random one. And let's multiply this. Multiply with a 0 point something like this. No, wait, something like this. Classic 0.12345. And then I'm going to add this. Did it change anything? It didn't. Oh wait, it did something. Okay, so it's still exactly the same for each instance for some reason. Right? It's still the same. Looks exactly the same as the last one. Okay, we're gonna figure this out. We're gonna figure this out eventually. So, what if I transfer this? What if I realize instances, right? Let's save this first. What if I realize instances first? And then, oh, you know what? The attribute is multiplied. Okay. And we are using a named attribute UV map, adding it with, let me just check a bit. Putting it into a UV map and then realizing instances. So I think that this is when it's operating on an instance level, it still doesn't work, right? So maybe we need to realize instances first. Did that do anything? Hey, hey, look at that. It is actually working. It is actually working. We have randomized UVs for each little rail. How amazing is that? Wow, I can't believe I actually managed to do it. Hey, I'm happy to be back. Hello, Max Later. Can you recap what you've done so far? So, what I've done so far is I was going from a Blender version to a Blender version and trying to explain why I couldn't do this exact thing that I just managed to do in the older version. So I used to use a 3.1 Blender. And the problem with that version is that the nodes that are called store named attribute and also input named attribute didn't exist. And now it exists. So what these actually give you, the power, is that you can so Blender used to always have the inputs position, normal, right? You can get a position, you can get a normal, you can operate on these, but there was no way to fetch UV maps, to get UV. No, okay, correction. There was a way, but it was a huge workaround. You had to import it from the base geometry through like custom attributes and then convert them it was a mess, right? But now there is this new input node which is called named attribute. Since 3.2, there is a named attribute, and you can actually select all these custom things that you couldn't do before. And the biggest problem in my case right now is that curve objects, because the object of this the type of this object is actually a curve, because the base you can modify the curve and then everything gets created automatically, right? The problem with that is that you couldn't fetch custom attributes from the objects that you reference. So for example, here, where is it? Object info. So object info is a node that where you can import kind of other objects into your object, right? Into your geometry node object. So in this case, I'm importing a pole, and so that is this vertical pillar, and also this rail, right? Which is down here, right? I get this object info. And I needed to get UV from here, right? But I couldn't do it. So the way I did it now is that, So there is this thing named attribute, and I'm actually fetching it from the object that you're pointing at with store named attribute, right? So I'm getting it, and what I'm doing here also is I wanted to. So why did I do all this thing? I did all these things so that I wanted to kind of wiggle the UV of each rail of this horizontal pole, so that you have unique UVs. Because you can see here, if you remember in the last stream, I made this UV, I made this texture. So my goal was, because this is the UV, I wanted for each segment. For each new segment, like this, I wanted to wiggle the UV a bit so that there's like a bit of variety in the texture. And what I did right now, 10 minutes ago, I managed to do this finally by passing an index of an instance to this not capture attribute. That's a legacy thing now. I wish I'd never use a capture attribute again, although I did have to capture the index again for the instance. So what I did here is that I used the index of the instance, pass it into my formula, which right now is actually, the formula is just multiplying the index, right? I'm multiplying the index and offsetting the UV for each instance. And that is how I get variety. So that is really, really cool. It's really, really cool that we can do that now. So now when you're driving around, you don't see the same goddamn, texture used for everything. But the problem right now is, so that's a little bit of a recap, right? The problem right now is that here you can see this seam, and the reason why this seam exists is because sometimes the UV, the randomness of the UV, if we look at the UV again, UV, if we look at the UV again, oh my god, it's so squashed. Wait a minute, did I not save this? Oh no, I totally forgot to do this. So yeah, this UV is actually still squashed. Okay, let's do this quickly. This is what I did at the beginning, and then I also what I did is I averaged island scale so that there's approximately the same textile density, and then I also rotated this so that you can see the vertical grains. The grain is in this direction. Okay. We can also offset the UVs of that, but the problem is that now, as I was saying, right now I'm just basically offsetting by a number. So what happens is that it goes kind of sideways like this, and when it crosses, because randomization is actually crossing this boundary on the left edge, so you get a wrap of this over this edge, which is not great, right? We don't want to have this wrap. So what I actually want to do is I want to just offset it vertically, right? Maybe that is enough for now, or maybe I'm going to wiggle it inside the space or something, or maybe I can just make a tileable texture. I mean, that could be a solution as well. So another thing is that, so right now, as I say, what I am doing in geometry nodes is that the index of each instance is simply multiplied. So if we look at so if we look at the instances, right? I need a viewer that gives us insight into the geometry that we are expecting. Okay, so if I look at the viewer, we can see that each of the instances has an index. And it's like 0, 1, 2, 3, 4, 5, right? And I started moving the animator accidentally. Oh, again, crazy. Okay, so we got this index, and then I'm just multiplying the index. I don't want to multiply the index. What I want to do is I want to randomly wiggle it. How do I do that? There is a random node. There's a random node, and I'm going to pass the index to the seed. And then instead of multiplying the index directly, what I'm going to do is, as you can see here, now it is just multiplying the value. Wait, why is it? Oh, that's interesting. Interesting. I didn't even plug this in. Oh, right, because I'm using a value. I don't want to do that, right? I don't want to pass in an UV. What I want to do is I want to not multiply, but let's add a random value to our Yeah, actually we don't need this anymore. What we need to do is we plug this. So we're adding the original UV map to this randomness. So let's see. Oh, I was changing a keyboard to Serbian. Not what I want to do. And as you can see, our seed is completely screwed. Okay, so maybe it's not a seed. Maybe it is an ID. Yes. So now, yeah, I should, yeah, kind of like I'm thinking like, what's the difference between a seed and ID? I guess when you set the seed, you can still have different, like, kind of like how in C# or any basically random number generators, you say next, 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 and then you get a new number, new random number. And so if you have a seed, you have fixed seed, but then each new number is going to be random. So I think that is why if you put your ID in a seed, you get this sort of skewed textures, because for each point or for each face corner, we have a random value, right? And which is actually not what we want to do. We want to have a fixed value for each of these IDs, right? And if we look at the whole thing now, we can see that there's randomness. So it's not like every instance is going to have the same thing, right? So yeah, let's actually bake this and then look at the UI, look at the UV. How it looks like. So if we convert the mesh, right, and we still have to apply, as we have found out, we have to apply converts. Wait a minute, did I save it? Okay, good. Let's save here before converting to mesh. Okay, we have to convert the attribute to the UV map. And now I can inspect the UV map, right? I say, okay. And as we can see here, this is what I was trying to explain. So what we're doing actually is we have a bunch of these islands, right? This is one of them. This is one of the poles, right? But the thing is that each of these instances have random number, and the reason the reason why they're in a diagonal is because I'm not using a random vector. I'm using just a number, right? So they get added to the same vector. So you know, this is going to be a vector 0.3, 0.3, right? This is going to be a 0.8, 0.8. So I add in both dimensions at the same time, right? But the thing is that I kind of want to have them all over the place, right, instead. But this is exactly what I wanted, right? I wanted to wiggle the UV for each of the instances, which is very nice, very nice. Okay, let's revert. So now, instead of using a single value, a single float, I'm going to use a vector. And what this does is it has a minimum 0 to 1, right? And so now if I apply this, right, let's save it, apply, converts, and then look into the UV, we can see now, or we can't, where is it? Did I accidentally not, oh, there it is. UV map, okay. What happened? Oh, maybe you can't do it while you're editing. Yes, okay. Wait, nothing happened. Let's do it again. Maybe I did something wrong. Maybe I selected the wrong mesh. Convert attribute, UV map. Okay. And then let's look at the UV. Oh, interesting. It did not actually get... What? It got added all of them got added to the same thing, right? So why is that? That's not exactly what I wanted. That's kind of weird. That's kind of weird. Oh! You know why? Because when I changed the type, it got disconnected. So I have to reconnect it again. Okay, now it should be random again, right? It's not random. We can see it's not random. The UV wiggle is not random. And adding this, now it is random. Nice. Okay, so let's apply this. And convert to UV map. Open the UV editor, and we can see now they're all over the place in 2 dimensions, which is exactly what I wanted. But I don't want the UVs to cross this threshold, right? I want all the UVs to be contained into this kind of thing, right? So what I need to do now is I need to kind of extract this. I need to I need to limit it, right? So we say, okay, multiply y by 0.5, and we want to have a minus, or maybe I'm just going to change the UV. Okay, let's do this, right? Revert. Instead, I'm going to change the UV of this thing to be, where is it? There it is. Because the multiplication of the adding happens up towards the up, not towards the down. So let's just put this in the corner here, right? And we say, okay, this is the minimal possible position. And then let's say that this one is here, and this one is maybe here, right? Because it should be similar. Something like this. But then, of course, move this slightly here. So that now I know that the possibility space is kind of over here, right? So I'm going to be able to move it by like 0.6 or something like that, and then sideways by 0.6 or something. Let's see. So now that we've changed this UV, and you know what? Let's do the same thing for the pole. So the pole, one side of the pole is going to, oh yeah, we don't actually know which side of the pole this is. So this, what is this? Is this the top or the bottom? This is actually the bottom. And this is the top, so it should be on the other side, and this is the bottom. Alright, this is what we should do. Okay. One and a half hours of streaming. Wow, it feels like I've already streamed for like 2.5 hours. Maybe because I'm just really quick this time. I've been talking a lot. I had 2 coffees. So. Anyway, yes. So we are sure that for this, I'm sorry, I should have probably isolated this. So these vertices are next to this thing. Yes. Cool. Okay, we can even align it a bit better. It shouldn't be actually the same, but it should be kind of similar color. So what we can do now is we can put this one in the corner as well, right? We can say, okay, put this in the corner, and we can randomize this one as well, which is not bad. I didn't plan initially to do that, but why not? So let's see, go into the geometry nodes, and now I'm going to limit this, as I said. Limit the vectors to go from 0. You know what? There is one more thing we can do, and that is we can add a viewer right? We can add a viewer for this geometry and look into the UVs, right? Let's look into the UVs. Viewer nodes, yes, face corner. Okay, so what we are looking here is that we are looking to not see any above 1 UVs. There actually are none. That's funny. Oh, here, well, because this is a random value, what I actually want is the UV, not this. Okay, yes, so in this, we can see in this case that this value is crossing 1. So what I want to do is I want to limit it within the 0. So max, like multiply by 0.5. Is that okay? I don't see any 1s. That's good. What if I multiply by 0.6? There are no 1s. Cool. What about 0.7? So what I'm actually doing is I'm wiggling this, what I was showing, like there's this imaginary limits of the UV, right? And we're trying to just make it not cross over into the next. So let's make it go to the 0.7. Okay, let's see if any of the values cross 1. They don't, which is perfect. Okay. So let me show you what I was trying to do, right? If I convert this, convert to UV map. Let's open the UV editor. Oh, it is actually crossing the UV boundary. Okay, so how did it seem like it doesn't in the viewer? Was I again outputting a wrong thing? My logic is flawed. Amazing. Okay. So yeah, I'm adding this vector to the outputting the value as a UV map viewer. There it is. Okay, viewer is actually, viewer is only 1. Okay, this is kind of a weird thing. Wait. What if I just... okay, let's do this actually. This is the wrong thing. Okay, so this is the actual UV map, right? This is the UV map. What I was doing there is that when you pass a value into a viewer, you can only inspect one value, I guess, and not the whole thing. So I actually want to do this. And as we can see here, here's some above 1s. So let's multiply this by 0.5, right? Let's see if now it crosses 1. It still does. There it is, 1.03. So let's move it to like 4.5, something like that. Any above 1? No. Okay, cool. So we're kind of in the limits now. And what about a Y? It's not crossing. The Z is not crossing either. Cool. So we can maybe even increase it to 0.8. Right? Any above 1s? No. Nice. What about 0.9? I'm just trying to fill up the most space. Okay, no above 1s. Interesting. So the random value, the Z actually is completely unnecessary because it's not using the UV anyway. So yeah, let's look at the UV map now. Shall we? Convert this into a UV map, and now let's see the UV editor. Look at that. Look at that. We are Oh, we are, wow, I'm perfectly on the edge by multiplying y by 0, 1. So as you can see, the reason why I was multiplying all that stuff, in case you didn't understand, is that I just wanted to make it not cross the one boundary line, so that I have that sharp once, which I don't want. So perfect. This is amazing. Okay, so it is wiggling the UVs, and all of them are now randomized. Let's revert. All of them are now randomized, and they look random. They look like they were picked from a bunch of. My God, this is amazing. Yeah, this is why geometry nodes are great. You can really, it's almost like I'm like programming custom geometry in like C sharp, you know, in like Unity or something. Or I mean any programming language, but it's just like, oh, now it's embedded in Blender and you can play around and you can view, debug your nodes and stuff. So great. We are now have this random textures. Let me actually, why don't I just show the, oh yeah, because that doesn't work. Can you actually remove lighting completely from this thing? Or can I show a material? No, I can't. But completely flat. No, it doesn't let me do that. So I just need to do this. Oh yeah, well, actually what I can do is I can remove specularity completely and increase roughness to maximum. So now it's a lot, yeah, the texture is a lot clearer now. Cool, cool. So let's do the same thing for the poles, right? For the vertical poles. Any questions so far? Are you enjoying the stream? Yeah. Anyone still alive? I might actually finish it up soon once I randomize the polls. Right? It's 12:13. Not even 2 hours of streaming. Pretty amazing. Maybe I'm gonna try it in game actually, and then I'm gonna end. But yes, first, let's do a geometry nodes. No one is alive on the stream? Okay. No one is writing anything. Everyone knows what I'm doing. Or they're just like listening in the background. I realized that I really need to get a new, like a better microphone. Is the stream working? It is working, right? Everything is fine. Because the quality of this microphone is kind of shitty. Yes, so let's do the same thing on the UV. But maybe I can pass an instance of an attribute. Like, let's capture this. Why don't we? What if I make a sub? How do you make a group? You say group. Make a group. Oh yeah, that is it. So I have the geometry. I have. So let's call this group let's call this group node group 0. How do you actually modify? the group. Okay, let's call this ID integer, and then output geometry, and then let's call the whole thing color. Oh, nice, you can color it. How do you rename this group? How do you go up? This is complicated. Oh, I see, node group 0. So I'm gonna say get instance ID. Back to previous. No, this is about wooden guardrail. Okay, get instance ID. There it is. What is this? Okay, it's just, oh, now it's even thicker than I thought it would be. But I can put it in one thing now. Okay, and I say get instance ID. And I'm going to have the instance and points, right? We get this instance, and in the same vein, I'm going to randomize a value with a UV map. Maybe we can even, like, okay, let's turn this into a group. And I say wait a minute. Wait a minute. Yeah, let's not actually do that. Can I undo it? Yes, I can. Good. It didn't like... The undo is in Blender is actually pretty cool. I remember back in the old Blenders, it would crash so many times just because like trying to undo and redo. But now it's really amazing. Like you can undo everything. Okay, so what I wanted to do is actually like collapse this into a node, but I'm not gonna do that now because I might want to modify all the values. So let's just copy it above here, and yeah, in the same vein as I do down here, I'm going to wiggle these, use the ID from here, and yeah, I'm wiggling the UVs, capturing the attribute, no, sorry, storing the attribute, which is a UV map, and then passing that, right, in the same way that I'm doing it for, and that should be it actually, right? I have a viewer, but I might actually move this viewer here, right? And then see if any of that, no, not that. And then see if any of this is crossing. Wait. Why doesn't it work? Let's actually check if it works, right? Like just visual inspection. Okay, cool. We do have some randomness, but it's very bad. I can see some of the seams. Oh, maybe I can just see the seams because this is where the seam is, in front. Maybe the seam should actually be in the back, so it's less visible from the player. But it is random, right? So that's cool. That's exactly what I wanted. But let's apply it. Convert to mesh. And then see how this is going, right? See how UVs, yeah, we have to, of course, convert our attributes into a UV map, right? And then let's, whoa, this is, what a forest of data. And as you can see, some of those are leaking outside, which is not what I wanted. But where are my pillars? My vertical ones. Oh, is that my vertical? No, it's not. So these small ones are verticals. And yeah, I can see that some of them are here, and some of them might be in here. What a mess of UVs. But if it looks good, it's good. I just need to limit the verticality to a little less. So this random, let's limit to 0.8. Oh, 0.8. So that we guarantee it doesn't leak. Cool. So this is kind of it when it comes to this guardrail, the wooden guardrail. Let's make it really long so that there's a lot of segments. And this is the most amazing thing about Blender Geometry Nodes, is how fast are they? It's crazy. Like, I'm just like spawning so many new instances, and I'm getting, like, this is such a long guardrail and still working. Amazing. So you can see how many guardrails we have now, how many instances we have. I just noticed something. That I don't like. And that is that actually our IDs of the vertical pillar and the horizontal rail are actually always offsetting in pairs, right? We can see that this one is like this kind of a light wood, and this is a darker wood. And so the reason why that is that we have the ID is always going to be the same, right? So for example, the ID of the, oh my god, it's such a long, it's so long. That's what she said. Like you have this index, right? We have the first one. So the index. So this is how it basically goes, right? Each of these slabs, or each of these, sorry, how do you call them? The pillars, as I call them, are each an index. So 0, 1, 2, 3, 4, 5, 6, 7, right? And these horizontal poles that I call rails are 0, 1, 2, 3, 4. So they're always the same, like 0, 0, 1, 1, 2, 2, 3, 3. So that is why they're all very similar, right? It's like being chopped of the same wood, all the pairs. But I actually don't want that. I don't want the pairs to be exactly the same. So what I'm going to do actually is offset some the ID, right, of this this ID, right? So instead of using the ID directly, I'm going to add. Let's add some ads. Let's add some add. And yeah, so now when we pass this ID, what we may see now is that we are offsetting it. Like, look at that. So when I increase the number, you can see how the UVs are now like kind of marching through, right? It's like, okay, if you see this one, when I offset it, it's going to be the next one. So now it's the same UV on the next one. Now it's the same UV on the third one, and so on. So I can just say, okay, offset it by 666, right? Because why not? So now it starts with 666, and so it's not going to be exactly the same. So that's a little bit of a variety. So yeah, now you can't clearly see the pairs of poles that look exactly the same. Right. So mission accomplished. Cool. Okay. And as you can see, we can make these giant guardrails now. So as a last thing today, I'm going to make them work in the game. So let's try it. The cool thing is that I can just copy this. I can copy my guardrails, right? And I can just be like, oh, okay. Yeah, have more guardrails. Here you go. Which I actually couldn't do with the old modifier stack, right? I can just have as much as I want. This is the best thing about geometry nodes, really, is that for each object, they're all following the same rules. So, okay. And to be honest, we should actually kind of wiggle the randomness as well for each of the new objects, right? What we can do is we can use the... So this is one trick where there is no... how interesting. Yeah, let's actually look for it. Does instance ID exist? Get instance ID. Oh no, that's the one. That's the one I made, right? But what is actually I think the ID? Add a nodes. I'm not sure what ID is. Is that the ID of the? Okay, so let's wiggle this ID. Not, I mean the object ID, not the ID of the index. Oh yeah, this is actually an index, not an ID, right? So I should actually call this. Get instance index. Index, not an ID. Index, right? Capital letters. Good. Let's go here, and then so we have the index. We can also collapse it. But I think that the ID is actually object ID. I'm not 100% sure, but let's try it. What I want to do is I want to add. I want to have an add. And add that. Add this index. More like this. To my value, and then pass that to the add. It's complicated. Whoops, no, not that. I didn't want that. I wanted to pass this here. Jesus, why are you... Okay. And let's do it like this. Okay, and then I want to pass that. Okay, good. So I'm adding these two together. So let's see if ID actually works. Let's see if this is the object ID. So if I copy this object, I should have a different... No! Okay, so ID is something completely different. As you can see, it's completely screwed up. I don't actually understand what ID is then. This is definitely not an object ID. Okay, so instead, so this is a little trick that you can use. Because this is what I realized, that Blender doesn't really have object ID. I thought that maybe added in the new version, but obviously they didn't. So it's like, what if you want to get a random number for each different object? The way you do it in Blender geometry nodes is that you can use position of the object as the source. So we're going to take a transform. How do you get a position of the object? Whoops, what the hell? Replace string. Transform. Can you get an input of the transform? Is there like a object info? So what does actually transform do? I think you need transform transforms everything. So that's not it. What I need is the position of the whole object. Okay, wait, I need to Google that. Blender geometry nodes. Geometry nodes position of object. Position node outputs a vector of each point of the geometry the node is connected to. Yeah, I just want one. For instances themselves, the output is the origin of each instance. However, if the node is for a geometry node that is just the data. Okay, so get global position. Original relative. So, oh yeah, what if I use an object info without anything? Okay, you need to provide it something. This is kind of weird. Like, you can't reference a self. How is that possible? Oh, right. I just remembered something. Attribute vector. I remembered now that actually you need to subtract the position somehow from the transform, something like that. What does ID actually do? Let's see. ID node gives an integer value indicating the stable random identifier of each element on the point domain, which is stored in the ID attribute. Unlike other built-in attributes, the ID attribute does not always exist. In that case, this node will output the index. Yeah, the ID is a weird one. I think that get random geometry node get random per instance, because that is how I found out how do I randomize value per instance. You can use set position. Okay, random value No, this is not it. Anyone knows how to get a random random number for the whole object? I remember there was this trick where you subtract position. Okay, I need to actually check into my other project how I did this. Okay, so let's save this, right? Let's save this. And I did it already once in a here. I was randomizing some windows for this little test scene. There it is. So when you move these windows, wait. So in this project, I was randomizing the UV of these windows. So if you move the object, you have random seed for each based on the position. So how did I actually do that? Let's remember that. There is this and face geometry object info relative. Oh right, now I remembered. This is such a hack. This is such a hack. You basically make a dummy object and then you reference it, and then you use a relative position, and then you can dot product it or something, and then you add it to your random value. Yeah, right. Okay, so can I do this? Control C, and then go into a different project, and then copy it. I don't think so. Did it work? Oh, I managed to copy it across projects. Wow. Okay, Blender is amazing. It can just copy arbitrary data between. Nice. Probably somehow serializes into text, so then it can decode it. Okay, so well, it doesn't know what origin is actually. So let's make an origin. Create an empty object, which is going to be called origin. Origin. And let's put it on the 0, 0, 0, 0. So now in my geometry node, I get an origin, right? Which I'm going to which I need to get by name, origin. And yeah, I do the dot product, and then I can use this into my whoops, I can use this in my, yeah, the reason why we use a dot product is just so we can output some kind of a float. And then, yeah, let's remove this. And then we can use that to add the number, like in this case. We add this value into this. We didn't even need to get a random number now. Okay, so let's see. Does it work? So when I move, I'm getting randomness. This is great. Everything looks good. Okay, so as you can see now, if I move my object, the UV gets randomized. Nice. So the two different UV, how do you call it? The guardrails are not going to have exactly the same sequence of UVs, right? UV unwraps, because right now they're always the same. It's always the same sequence. But with this added, when we move it, we get a random sequence, but only for the poles, right? Now let's add that to here. Actually, I am going to convert this into a random value. Let's make this into a group. Make group, and there's no inputs. We're gonna call it origin, and let's see, the dot products, and let's just call it random object random number, something like that. So now we can actually use this dot product. We can use a random and use a, I don't know, something like this. We put it into the seed. I think this is probably gonna work. And get a, let's have, I don't know, 20,000 or something. Maybe I can have, I don't know. I think that this is gonna be fine. This is gonna be fine. So yeah, good that we have this object number, this custom the random number per object. Okay, so random objects random number. Okay, now let's just check if everything looks good. So now if we move this, oh no, everything is broken because we use the seed and not the ID. Right? So I still don't understand quite the difference between ID and the seed. Yeah. Okay, so guardrail, and now it works, right? We have different IDs. Okay, cool. Now let's do this exact same thing for the other thing, which I completely forgot how it's called. For my rail. So I'm adding the number here, right? This is the instance index, and yeah, I'm going to add this. Let's do it like this, so it looks a bit nicer, not overlapping. And we're gonna use this, right? Perfect. Okay, so now we have different UVs also for each different object offset. Perfect. So that's about it. Let's put some guardrails on the track and test it, and that's pretty much it. I can end it there. Back to previous, save this, and let's see the whole map now. Monty. Okay. Yep, we have rendered the whole thing. What is this? Guardrail test. Let's remove these guardrail tests. And instead, I'm going to have a let's add this into a new thing, new Monty collection, guardrails. Okay, guardrail test 2, let's add it and say guardrail wood. Okay, good. So now we can just yeah, where should I put it actually? Well, I can put it on the side here, for example. I can put the first one over here. No, let's put it where it really matters, which is here. Oh wait, I already have a wall here. That's weird. I thought I removed this wall. Wait, is this some kind of an object that's leaking? That should not be there. I have a feeling like I removed this. Okay, weird. So where are we? What is this blackness? Why is everything black? Oh, because I have two mountains. Okay, this is how it should work. This is how it should look. Okay, so where should we put this? Where should we put this for the first test? Actually, let me just put it next here, like, because this is where I actually begin in the game. Okay, so put this one thing here. Is this the correct orientation? It is. Okay, so we're gonna put one and here. A bit harder to see. The other is going to be on this side. So this is now for the first time we're actually using it for something useful. The geometry nodes that I was working for 2 days on. Well, technically only on the streams, so not that long. Okay, so let's take it to the wall, right? To this wall. And yeah, let's end it here. So now let's put it on the ground so that it doesn't float in the sky. Let's add some shadows and some cavity so that we can see how far from the ground it is. A bit easier. I just realized I didn't listen to any good music for a long time, like a few days. Just a random figuring out thing. Something, yeah, it's kind of a weird wiggly, noisy piece of the road. Okay, so yeah, let's rescale this a bit, and then also finally the one remaining thing we can do is this. Oh yeah, by the way, we might on the next stream I might use a node. I found out that there's a raycast node with which you can raycast into, for example, the ground, right? You can raycast into the street and then place them like so that it doesn't float. So that I don't need to place I don't need to hand place everything, right? Okay, but it's fine. Okay, for now it's fine. So let's turn on the full view with the textures. Everything looks great. Oh my god, it's so sexy. Okay, let's actually turn this off. And so that we don't look into the origins of my nodes. Oh, wait a minute, what is this? This is something I don't need. Okay. Cool. So we have this. And let's try now to export this. And cross fingers that it's gonna work fine and not crash my game. Which can happen. So let's see. I don't want to output the origin for sure. And I do want to output the sun cube. Save it. What? I don't have GLTF. Please. Okay, GLTF exists. That's good. That's good. Shakedown. No, let's output directly to an engine and... Okay, there it is. I've saved my presets. Selected objects, visible objects, no normals, vertex colors. Monty Road, the GLTF. No, not that, actually. Not the projects one, but the source. CPP. An engine. Where is it? An engine. There it is. This. An engine. Drive. Bin. No, res. Models. Monty Road. Whew, okay, let's cross my fingers and press export. Oh, I just realized that I can't actually, I didn't apply this. Right? So actually, let's see if it works. Let's see if I have any UVs on this. So we can start it directly from CPP folder and engine dev drive bin release. Yay, it works. Cool, and we have... Hello, the funny thing is that I didn't enter the game at all. We have... Oh, there's the headlights are even still there. We can see that the barrier is there, but it doesn't have any UVs, as we guessed. Oh, actually the collisions are super... Oh man, it is a bit fucked up. So I'm going to need another collision object for sure. But it does kind of work, right? We can see that the collisions, even the collisions are working. But yeah, the problem is that I didn't apply. You know, we need to convert. We need to convert our nice UVs. So save this. Apply, convert into mesh. Attributes. Convert attributes into UV map. Okay, yes, now it has become the UV map. Now what we can do is we can export. Why is this not in quick favorites? I don't know. Export as Monty Road with all the properties. Now let's start the game. And this still doesn't work for some reason. Right? No, it does work, right? There is some texture on it. Oh, wait a minute. Oh no. The wheel has sunk through the tiniest of gaps. Nice. Okay, so yes, there it is. The texture is there, but for some reason when it's not lit, it's completely black. So why is that? Why is it so dark? Oh, well, I'm stupid. I totally forgot I didn't bake. It's because of the vertex colors. So I need to add colors, which is going to be per vertex color and per face corner, and I need to call it the light map, I think. I can't remember if I need to or not. So yes, let's try to export it now. Nope, still black. Okay, so maybe I also need to bake it, right? I need to bake. Yeah, right, it's going to be totally black. So that's another problem. Can you not? I have a feeling like you could. Oh, right, this is it. There's actually a new thing which is an input color, which I didn't see until now. I actually can make it white, so that it's always white and not black, right? So that all the properties are white and not black. So now I can export it, and I think this is going to be it. It's just so many steps that I need to remember. There it is, except I've only exported the guardrail. I totally forgot that I should export everything. There it is, finally. It's colorful and nice. Okay, so let's turn around. Let's actually turn off the annoying frame buffer so we can do it full screen. And we can... Some weird physics bugs. There it is. Randomized, procedurally generated guardrail from wood. Made of wood. How beautiful. Now, yeah, I kind of need some shading actually now when I'm thinking about it. It's too flat. You see how this wall on the right side is actually nicely shaded? Oh, there's some kind of a weird texture Z-fighting. Oh, there's probably multiple overlapping objects. Yeah, I need to fix that. But the thing is that I made this into this texture. There's actually a bit of darkening, and there's no darkening in my guardrail, so I'm going to need to add some. So yeah, let's slowly sign out. Thank you for watching. I've finally got my procedural guardrail in, and thank you. This has probably been my most kind of wordy stream so far. I talked a lot, and I actually like. It's actually a lot easier to talk and work in 3D than it is to program and talk about programming, because it's so abstract. I can't. It's hard to show. So yeah, it's much easier to. Nice bug there. It's much easier to 3D model or do geometry nodes and then explain things, and then I can actually show you, and you can see all the results live. So yeah, I forgot that I can actually look at it from a nicer camera. Cool, and it's all randomized and it looks nice. And yes, also pixelated. Maybe, you know what, I can maybe add like a little... yeah, this is going to be a bit difficult because I'm going to have to align things. You can add a little sprite on the bottom, like, you know, like just have a little shadow blob. Like old games did this, where they would just add a tiny shadow blob to like... yeah, to like make it a bit like ambient occlusion without using actual ambient occlusion. So yeah, looks good. Looks like it's now some kind of a farm. Cool. Okay, so thank you for watching again, and hope you learned something. Hope I showed it well. Let's make a circle around the village. Now I want to make everything in geometry nodes, right? I could maybe make the buildings. I'm going to actually explore making buildings with geometry nodes next. Look at that. Beautiful. But I should probably move that to another place. Okay, so thank you. Thanks a lot again. And nice wooden rail. Good job. Thank you from Nadine Gaming. Cool. So, see you next time. I don't know what it's going to be. Probably not this week. Probably not like tomorrow. I don't think so. I don't think. I don't know. Actually, might stream again tomorrow if I find something interesting to do. And the weekend I'm going to be busy, so probably not. Okay, thanks again. Thanks, NasCB. It looks so good. Nice job. Good. Okay, one final look at the guardrail. There it is. Nice. Okay, cool. That's it. Okay, that's it, folks. Thanks, and see you next time.